Good day everyone, my name is Oswagu Samson Ikedinachi. Chemistry Hangout is the best channel I can ever recommend for any student who is wanting to write WAEC, NECO or JAM. In fact, it is the best channel. It really is the best channel because it really helped me a lot. It helped me a lot in my WAEC and my NECO. I wasn't good in chemistry at all, but when I joined this channel and I listened to some kind of teachings over the channel, I really loved it, and I can say it really helped me a lot. It really did. It helped me a lot. So for you who is wanting to write WAEC, JAMB or NECO, I really recommend you to join this channel. And also, don't forget to subscribe. Just click on the bell button there to give you notification and subscribe.
Hello, good day viewers, you're welcome to Chemistry Hangout. You are just watching this YouTube channel for the very first time. I want to welcome you to one of the best chemistry channel on YouTube that will enable you to understand chemistry the right way. You are a subscriber on this channel. I want to welcome you to another wonderful section on this very particular YouTube channel. For you that are watching this channel for the very first time, kindly click on the subscribe button and click the notification bell so that when I upload any video, you are going to be notified. So I want to welcome everybody to another wonderful teachings here today. Very quickly, we started a series and we're going to complete that. And for people that have reached out to me, for GC students that have reached out to me, I have uploaded videos that will guide you on the question to expect for GC. If you are doing NECO GC, NAPTEP exam, all those exams I just mentioned, they will be giving you alternative to practical. So they are the same, they are going to be the same prototype. Like the questions, the predicted questions, the way they will give you the questions are going to be the same. NECO GC, NAPTEP exams, their practical are alternative to practical. So you can use the one I have uploaded on the channel as a guide. And I want to believe if you do diligence to it, if you have watched that very particular video and you understood all what has been done there, then you don't have problem as regards the exam. So very quickly, I want to continue the series I started. A lot of people have been, a lot of people have been chatting me, reaching out to me that Chemistry Hangout, we love that series. And the reason why I actually did this series is because I saw a whole lot of students, even undergraduate, A-level students, finding some of these things difficult. So that's the reason why we have to build capacity from the scratch so that we can understand. So you are a student, pay attention to this, an undergraduate, and if you are a co-teacher like me too, I want you to pay attention to this video. I believe we can learn from ourselves. Okay, so you can pay attention to it so that it can guide you the way to actually build the student capacity to understand this very particular topic. So what is the series we started? We started naming of inorganic compound. That's IUPAC nomenclature of inorganic compounds. And if you remember, I gave a simple test. A lot of people reached out to me that they actually failed the test, but don't worry, that's why the channel is here. So I quickly gave that test and asked people to name it. Some people were able to, some people were not able to. In fact, some people were chatting. I was like, this name we don't understand. I said, don't worry, we're going to build capacity. So that's where we are starting from. So let me quickly, talk about what we did in the last class. We talked about, if you remember, we discussed about valency. If you remember, we discussed about valency, where I gave the valency of, some elements. I gave the valency and I said, if they give like this, sodium, which is 11, which is 281, we talked about that. If it gives, it becomes this, okay, which means the electronic configuration is not going to be 2,8. We have talked about this, and we have looked at the valency of at least the first 20 elements. So I want to believe you are following. If you are just watching this very particular video, or you are new on this channel, you have not watched the previous series, please do well to go and watch it so that you will not be lost, so that you can flow with us. So very important, we have said that it is possible for an element to give like this, and it's possible for an element to connect like this. This becomes 288. Why? Because chlorine is 287. So immediately chlorine connects one, it becomes 288. So, and we said that if an element gives, it becomes an ion. If an element gives, it becomes an ion. Because an ion, or collect, it becomes an ion. Because ions are ions are atoms that possess charge, either negative or positive. I'm just trying to, take us through what we have done. So you understand valency now. we already understand valency now. We understand valency now. How valencies are formed, we understand. How we can have their charge, we understand now. Now, very quickly today, I will now talk about polyatomic ion. That's my bone of contention today. I'll talk about polyatomic ion. We are familiar with the word ion. I just explained that ion are atoms, okay, that possess charge, either positive or negative. Now, when I now talk about polyatomic, from the word atom, polyatomic meaning many atoms. So it is possible for a group of atoms to possess charge. So when you talk about polyatomic ion, you are talking about group of atoms that possess charge. That's what we are talking about. Group of atoms that possess what? Charge. So the charge may either be positive or negative. And sometimes they are called, another name for them is we can call them radicals too. Some people call them radicals. So is that we call them radical? When you hear me say radical, it means I'm talking about group of atoms that possess what? Charge. Or I talk about polyatomic ion. So radicals, polyatomic ion, anyone you have used is correct. Now, don't forget I said a single atom can give an electron or collect to be positive or negative. And I said if it gives, it becomes positive. If it collects, it becomes negative. So I will give some familiar polyatomic ions. I'll give some familiar ones. We have a lot of polyatomic ions. But I'm going to, give you some that are very familiar. And as you grow in chemistry, you begin to understand a whole lot of them. So I will say polyatomic ion. So let me give few. Let me see if I can give few. I have CrO4 2 minus. Okay, CrO4 2 minus. Oh, you can see this is just a group. This has chromium, this has oxygen, and all of this now sharing this 2 minus, meaning all this compound collected to. That's why we are seeing something like this. So I have CrO2 O7 2 minus. These are polyatomic ions. Okay, these are polyatomic ions. And we have MnO4 minus. And we have CO3 2 minus. And we can have SO4 2 minus. I can have SO3 2 minus. I want to believe you are still following. I'll give their name, don't worry. Let me just list as many as possible. And we have ClO4 minus. And we have ClO3 minus. I can have ClO2 minus. I can have ClO minus. These are just familiar ones. I can have. Let me write them here. Let me come here. So I can have, from here, I can have NO3 minus. So if I can have NO2 minus, what other ones can I have? So that we can, understand. I'm giving this. Okay, I'm giving this. Okay, let me have PO4 3 minus. Can have these two. I'm just giving some fun. We have a lot of polyatomic ions. We have a lot of them. We have a lot of polyatomic ions. So all these guys, if you look at it, this very particular group of atoms has 2 minus charge. This very particular one has this. This very particular one has this and that. Now, if you remember in my last video, I said when you want to name inorganic compounds, we have 2 ways. I gave the old name, if you remember, I gave the old name and the IUPAC name. So there are some of these, polyatomic ions that have their old name. So I will give their old name now and teach you how to use the IUPAC nomenclature method to actually do their naming. So let me give the old name now. The old name. Let me give the old name. So if you remember, if you have watched that video, if you remember, I told you, I said you can use two ways. You can use the old name, you can use the IUPAC name. So the old name for this is chromate ion. The old name for this is chromate ion. The reason why I'm putting ion is because of the charge. So when they have charge like that, you can put, so this chromate ion, this chromate. So you have to know all these things. You have to know them. This dichromate ion, this manganate, MnO4. Okay, the old name can have permanganate ion. Permanganate ion. Don't forget, I'm still talking about the old name. This one, we can have carbonate ion. The reason why the ion is there is because the charge that they are carrying. So this is carbonate. This is sulfate ion. That's number 5 now. Sulfate ion. This is sulfite. This is sulfite ion. Okay. This for our ClO4. This is perchlorate ion. So the reason why the ion is there is just telling us that they have charge. So this is chlorate. These are their old name anyway. This is chlorate ion. This is chlorite ion. This is chlorite ion. This is hypochlorite ion. So this is nitrate ion. This is nitrate ion. This is nitrite ion. This is phosphate. This is phosphate ion. This is phosphate ion. You can see these are their old name. So the reason why I'm just putting the ion is because of the charge they are carrying. So this is chromate, this is dichromate, this permanganate, 4 carbonate, 5 sulfate, 6 sulfite, 7 perchlorate, 8 chlorate. Now you just have to know this. That's what I'm giving. We have a whole lot of radicals, but you know, as you grow in chemistry, there must be some things you understand so that you don't get yourself confused. You need to know this. But now for easy naming, that's why the IUPAC naming came. You know, I told you, I said these are their old name, but for us to be able to name them better, that was the reason why they now introduced the IUPAC name. And you see, the IUPAC name is more even easier than this to me. That's the reason why if you check the last video, I did the old name, I did the IUPAC name. So the IUPAC name, now how do we name them? We name them using the method of oxidation number, which is the maximum number of electrons. Name them using oxidation number. And when you talk about oxidation number, you're talking about the maximum number of electrons an atom can actually give or collect to form a chemical bond. There is a little difference between valency and oxidation number. Sometimes they can be equal. Your oxidation number can be the same with your valency. But for valency, you must have whole number. Valency and whole number. By your oxidation number, you can get a number that is fractional. Can you see? So, but sometimes they are very close, but there are thin differences, thin line that is separating them. For valency, your valency cannot be fractional. Your valency must be old number. That's what I mean. Valency will always be old number, which means you cannot have valency of plus half. No, you can't have it. It can only be 2 plus 3 plus. You understand? But in oxidation number, you can have a fractional number. Do you get that? You can have a fractional number. But sometimes your valency too is equal to your oxidation number. So you just have a slight difference between them, but they have similarities too. Now, for us to calculate oxidation number, I'll give us this rule so that I'll be able to name this. That's why I said go and watch the first video. If you have not watched that, this thing will be giving you a whole lot of issues. So the rule, the number one rule is that the sum of oxidation number of a neutral compound is 0. The sum of oxidation number of a neutral compound is 0. 2. The oxidation number, just 3 rules I'll give. The oxidation number of an element in its free state is 0 also. So number 3 now, the third rule now. I said I'll just give you 3 rules. So the third rule now, the sum of oxidation number of a polyatomic ion or radical is equal to the charge on it. So these are the three rules, and I will explain. The first one, let me explain now. The first one, the sum of oxidation number of a neutral compound is 0. What am I trying to say there? What I'm trying to say is, let's say for example, they ask us to calculate oxidation number of H2SO4. Is this a compound? Yes, because it has 2 or more elements. So for me to do anything here, I have to equate this compound to 0. That's the meaning of the first one. The sum of oxidation number of a neutral compound is 0. So the sum of oxidation number of this one is 0. I will now need to calculate for any element they want me to calculate. So because if you are given a compound like this, the question will specify the oxidation number of the elements they want you to calculate here. Do you get that? So that's the first rule. H2SO4 is equal to 0. So any compound, before we do anything, they will calculate the oxidation number of any element there. We have to equate it to 0. I want to believe that is clear. The second one, the oxidation number of an element in its free state is 0. What do I mean by that? If I have an element like this, this is not a compound. This is an element. Can you see that? So if they ask what is the oxidation number of zinc here, is what is 0. Why? The meaning of in its free state means it is standing alone. So when you see any element standing alone and they ask you to calculate the oxidation number of that element, it is equal to 0. I want to believe that's clear. So don't confuse this for this. Do you get that now? This is a compound. The sum of the oxidation number of all this is equal to 0. Why? Because in chemistry we say it is electrically neutral. So when something is neutral, it means it doesn't carry any charge. Do you get that now? So this is 0. But the oxidation number of elements in its free state, when an element is standing alone, it is 0. That's the meaning of the second rule. I want to believe that's clear. Number 3, the sum of oxidation number of a polyatomic ion or radical is equal to the charge on it. Please pay attention to this. Very important. Meaning, let's say for example, I have something like this. They now ask me to calculate the oxidation number of something here. They want me to calculate the oxidation number of, let's take for example, nitrogen here. I will equate this to the charge on it. What's the charge on it? Minus 1. Can you see? So that's the meaning of the sum of oxidation number of a polyatomic ion is equal to the charge on it. Why if I have this? This is an ion too. They ask me, calculate the oxidation number of sodium here. It's 0 and plus 1. Do you understand? So the only difference is they will specify the elements to get the oxidation number here, but don't forget it's still equal to the charge. Why this one is already an ion is equal to the charge on it. So that's the meaning of the rule. Now I want to use that now to name this. I'll just name few, then I'll give you other ones to do yourself so that you can practice. So I want to use, don't forget, we have said this is the old name. I want to use the IPAC name now. I want to use the IPAC name. To me, the IPAC name is much more easier. It's much more easier. Now, before I start that, note this. Note this. For naming inorganic compounds, we usually use something we call prefix. Prefix, like for 1, we use mono. Okay. For 2, we use di. For 3, we use tri. For 4, we use tetra. Okay. For 5, we use penta. For 6, we use hexa. For 7, we use hepta. For 8, we use octa. These are prefixes we should know. You know your normal polygon name now. For 9, we use nona. And for 10, we use deca. Okay, so we should note this. Very important. Note this. And another thing I want us to note is we use Roman numerals too. We use Roman numerals. You are familiar with that. Roman numerals, you know this for 1. For 2, you have this, you know. For 3, you have this. You get that, you know all this. For 4, you have IV and the rest like that. So these are our normal basic mathematics. Now, let's start to name this now. You know we have 40 polyatomic ions, so I'll just do 10. Then I'll ask you to try other ones yourself. So that you can use the comment box section to tell me their name. So I want to use the new name now. Now look at it. When you are naming polyatomic ion, you start from the last atom. The last atom. If you look at this is chromium, this is oxygen. Okay, we start from the last atom, oxygen. How many oxygen do you have here? That's what? 4. Okay, so don't forget for 4, what do we use? Tetra. So I will say the first name now, the IUPAC name now. You know the tetra. Okay, this is oxygen. Our oxygen changed to oxo. We don't use tetra oxygen because you still have other elements you want to name. You have other atoms you want to name there. So we change our oxygen to oxo. Do you see that now? If it is iodine, we change it to iodo. Do you get that now? So for this now, oxygen, if it is chlorine, we change to chloro. So for this now, tetra, okay, oxo. Can you see that now? What do you have now? Chromium. For chromium, that's the last atom now. For chromium, we add the ATE. When it is the last, we add the ATE. So instead of chromium, we say chromate. This. So this becomes tetra, oxo, chromate. So chromate what? You need to calculate the oxidation number of chromate here. That's where all this rule is now important. So let me show us now. We want to calculate the oxidation number. CrO4. Don't forget, you have 2 minus on it. What's the third rule? It has to be equal to the charge on it. So this becomes minus 2. Can you see that now? Chromium, that's what you are looking for. We are looking for the oxidation number of chromium here. It assumes X plus. Look at oxygen. We have said that in our last video. What's the valency of oxygen? Used to collect 2. So that's 2. That's minus 2. The charge is important here. So oxygen used to collect because oxygen is 8. That's 2, 6. It will collect 2. So it will assume minus 2. So that will be open the bracket minus 2 times this 4 equals to minus 2. So X plus times minus, that will be minus 2 times 4, that will be 8. Then we have minus 2. Guys, I'm teaching you how to calculate the oxidation number now. So from there we have X equals to minus 2 plus 8. Then X will be what? Plus 6. Can you see that? So which means this will be tetra, oxo, chromate, what? 6. So we write it in Roman numeral. 6 is 6. I want to believe you still remember this. This is 6, then ion. So the name of this, can you see that now? So the name of this is tetra, oxo, chromate, 6 ion. Why am I putting the ion? Because of what? The charge you have here. So this is the old name, chromate ion. This is the new name, tetra, oxo. This is longer, but it's more understandable than this. Because if you are not used to chemistry, you might not understand that even they have old name. So, but the new name will be us. So let's see the number 2, the new name now, which is the IUPAC name. Can we try this? Look at this. 7. What do we use for 7? Hepta. Can you see? So this will be hepta. Okay. Oxygen are being reused oxo. Can you see that? Chromium now. Look at chromium. You have how many chromium? 2. And for 2, what do we use? Di. So this is hepta, oxo, di. Can you see that now? Chromium, we use chromate. Chromate what? You now calculate the oxidation number here. So it will be Cr2O7 equal to minus 2 equal to the charge on it. So we are calculating for chromium. That will be X times we have 2 plus oxygen used to collect 2 minus 2 times 7 equals to minus 2. So this becomes 2x. Okay, 2 times x, 2x plus times minus 2 times 7, 14 equals to minus 2. Can we see that? 2x equals to minus 2 plus 14 because it goes to this side. So we have 2x equals to what? Plus 12. Why x here? Divide both sides by 2 gives us plus 6. Can you see that now? So this is hepta, oxo, dichromate what? 6 again. Can you see the way I got those names I gave you as test now? Let's take a look at this too. Let's take a look at this. We are naming this now. That's number 3. I'll still rub off this. Please, you can take your time to write this so that we can be doing all those things there. So, look at this. Let's start. Can we do that together now? 4. That will be tetra. Okay? Tetra. Oxygen. That will be oxo. Okay? Manganese. Can you see? This is manganese. Mn. Manganese. So, that will be what? Manganate. Okay? So, that will be manganate. Manganate what? We have to calculate the oxidation number of manganate here. So how do we do that? Let me quickly rub off this. So I expect you to have written this. If you have not written this, you can just take the video back so that you understand. So manganese now, don't forget the rule, MnO4, that's what we are calculating, equals to, this is minus, so it will be equal to -1, the third rule, don't forget. So that will be x plus -2 times 4 equals to minus. I want to believe you understand how I got this. So x plus times minus, don't forget oxygen is the one that collected 2, so that's why it's minus times 4. So plus times minus, minus 2 times 4, 8 equals to -1. So x will be -1 plus 8. So x will be what? Plus 7. So this will be tetraoxomanganate 7, the Roman numeral 7. So can you see? These are how I got those naming I gave you. These are how I got those namings I gave you. And I want to believe you are following. I want to believe we are following. Okay, can we do this together? Can we do this together? Okay, let's see this one now. Look at that. Tetra. Can you see? They are easy. They are easy. That's why you have to just keep practicing this. You will begin to grow in chemistry knowledge, then you'll be able to do it. But before we do that, let's quickly calculate oxidation number of sulfur so that we can just name it. So this one will be SO4 equals to -2. So we are calculating for sulfur, that will be x plus -2 times 4 equals to -2. So x minus 8 equals to -2. X equals to -2 plus 8. X equals to plus 6. Mathematics, right? Plus 6. Okay, so which means this one will be, can we do that together now? This one will be tetra. Okay? This one will be tetra. Okay, we are doing this. Is it carbonate? Okay, sorry, we are doing this. We are doing number 4. So let's calculate number 4. Number 4 is CO32, but you can just leave this since we have calculated this, so we use that for number 5. So let's name number 5 first, then we go back to number 4. So number 5. So we have calculated the oxidation number of sulfur there. So it becomes this now. It becomes tetra. Okay? Oxygen becomes oxo. Can you see that? The symbol S element, S is sulfur. So it becomes what? Sulfate. Can you see? Sulfate. So sulfate what? 6. We have calculated that. 6. Okay, yo. Don't think I'm writing. So 6. Can you see that now? Very clear. Let's go back to number 4. So let's go back to number 4 now. Let's go back to number 4. So number 4 now we have CO3. That will be -2 because that's the charge on it. Can you see that now? So let's calculate for carbon here. X plus -2 times 3 equals to -2. X minus 6 equals to -2. X equals to -2 plus 6. X will be what? Plus 4. Can you see it is easier? So from here, now look at this. So we are doing for number 4. What do you have here? 3, right? What is 3? Tri. So that means number 4 will be tri. Okay? Tri. Oxo. C for what? C for carbon. So we change to carbonate. Trioxo carbonate. Carbonate what? 4. Right in Roman numeral 4. Can you see? The iron name looks longer, but it is easier to name than the old name, because if you are not used to chemistry as a subject, you might not even know the old names. Okay, so this one is preferred. So in an exam, this is more accepted. Number 6. So we have SO3 2 minus. Let me cover this so that I can do that there. Let's calculate for sulfur here. SO3 2 minus. So that becomes what? -2. Very fast. X plus oxygen is collecting to -3 times 3 equals to -2. X minus 6 equals to -2. X equals to -2 plus 6. X equals to plus 4. Can you see that now? So which means number 6. Let's go now. Let's go number 6. Tri. Can you see that? Tri. Number 6. Tri. Oxo. Okay. Sulfate. Can you see? Sulfate what? We have done the oxidation number. Sulfate 4. Can you see? So as you begin to do all these things, there are sometimes you just see the polyatomic ion, you already know their name because you are used to them. But for now, you need to keep practicing, keep practicing, keep practicing. Number 7. Let's go. Number 7. Let me rub this so that I can be calculating our oxidation number here. So number 7, can we go together now? 4. So that will be what? Tetra. Oxygen, that will be oxo. Chlorine, that will be chlorate. Okay, So let's see the chlorates there now. That's ClO4 minus. So ClO4, since it is minus, it becomes minus 1 because that's the minus on it. So from there we calculate for chlorine there, that will be x plus minus 2 times 4 equals to minus 1. X from here it becomes what? Minus 2 times 4, that will be minus 8 equals to minus 1. Can you see that now? So x becomes minus 1 plus 8. So x becomes plus 7. Can you see that? So this is the tetraoxochlorate 7. In Roman numerals, chlorate 7. I want to believe we are following. Let's do this now. Let's do this. That will be trioxochlorate what? Let's calculate ClO3. It will be equal to what? Let's see if we have minus 1. So we have minus 1. So this will be x plus minus 2 times 3 equals to minus 1. X minus 6 equals to minus 1. S equals to minus 1 plus 6. Then x equals to plus 5. You can see from the start of this, it's just like I'm doing repetition. So number 8. What is number 8 going to be? Now number 8, that will be tri for 3. So that will be trioxochlorate. Chlorate what? Let's see, chlorate 5. We have calculated the oxidation number. Chlorate 5. I want to believe we are following. So it's not as difficult. It's not as difficult as we think. I will leave this 11, 12, 13. You can use the comment box section to tell me what it is. I want to believe you should be able to name it. So let me do the 9 and the 10 now. Let me do the 9 and the 10. So let me rub off this too. So let me come here and do the number 9. So the number 9 now, can we do that together? 2. What is do? Di. Can you see that? Di, that will be di. Oxygen, that will be oxo. Chlorine, that will be chlorate. So let's calculate the oxidation number now so that we can name correctly. So that will be ClO2 equals to minus 1. Can you see that? For chlorine, that will be x plus minus 2 times 2 equals to minus 1. Then from there, we become x plus times minus 2 times 2, 4 equals to minus 1. So x will be minus 1 plus 4. And x is going to be what? Plus 3. Can you see that? So this becomes dioxochlorate 3. Dioxochlorate 3. Then the last one, which I'll be doing, then I'll leave you with this to just try out. This is 3 here. So the number 10, look at this ClO. So we don't have any numbers here. So which means this will be oxo. Can you see this will be oxo? Then chlorine will become chlorate. Oxochlorate. Chlorine 1, let's calculate the oxidation number. ClO equal to minus 1 because it's equal to the charge on it. Okay, x plus minus 2 times 2. Sorry, x plus, there is no 2 here. Sorry, that's a mistake. X plus, we have only oxygen here, that will be just minus 2, okay? Equals to minus 1. So x plus times minus 2 equals to minus 1. X will be minus 1 plus 2. Then x will be what? Plus 1. Can you see that? So this is what? Oxochlorate 1. I want to believe this is so. The IPEC nomenclature looks very, very, it looks long, but it's easier if you understand this step. So for you that you're watching me, try to name number 11, number 12, number 13, and number 14, and put the name in the comment box section. Yeah, put the name in the comment box section so that I can see if you understand it. And you want to agree with me that if you understand all this rule, you will be able to name compound. Don't forget, today's series we talk about polyatomic ions. I gave the old name first, then I explained oxidation number, explaining the rules, then I used the oxidation number method. If you understand, I use the oxidation number method to actually name this. So you are using the oxidation number method to name 11, 12, 13, and 14. So as you keep growing in chemistry, you begin to understand all those things. They are not magic. This is how it emanated. This is where it emanated from. This is how we build capacity in chemistry. So do this 11, 12, 13, 14. I want to see the comment. I want to see the name of this in the comment box section. Yeah, I want to see the name in the comment box section so that I will see if you are following me. I'm still coming back. I'm not done with this series because I just started naming polyatomic ions. I have not named covalent compounds and ionic compounds. So the series is still on, because as much as you now understand how to name polyatomic ions, then we can now merge them together for you to be able to name bigger compounds. I want to believe this clear. So today we have successfully learned how to name polyatomic ions using the IUPAC nomenclature method, oxidation number method to be precise. So in my next video, I'm now going to explain how to name covalent compounds, how to name ionic compounds. And if you really want to know that, you must be able to differentiate between ionic compounds and covalent compounds. So in my next video, we'll talk about covalent compounds, ionic compounds, what's the difference between them, how do you differentiate them, how do you know this is a covalent compound, this is an ionic compound, then how do you name covalent compounds, then how do you name ionic compounds. So we still have a long way to go, so that at the end of all the series, we can say that, of course, a whole lot of compounds, especially inorganic compounds, will be able to name them, a whole lot of them, and that is nothing but the truth. So if you are watching this YouTube channel for the very first time, we have not started yet. You have a long way to go. You have to subscribe to this channel and click the notification bell so that when I upload video, you are not going to be left out. The series is still going to continue. In my next video, we are going to continue naming IUPAC compounds. Till we meet again. If you are a subscriber already, I love you. Thanks for the word of encouragement. Thanks for the motivations. Thanks for the prayers. Those are the things that keeps us going. Okay, I want to believe we have been imparting on this very particular channel, and it is your motivation, your prayers, your encouragement that has been keeping us going. So don't stop doing that. We love you, and we'll not stop giving you the best on this very particular channel. Don't forget, this is Chemistry Hangout, one of the best YouTube channel as far as chemistry is concerned. Do have a wonderful day till we meet again. Thank you.